Good morning. Today we're working with multiplying rational expressions and adding and subtracting rational expressions with a common denominator. So this is 5-2 and 5-3. 5-3 kind of A is the common denominator for adding and subtracting. The next video, 5-3, will be uncommon denominators, so that will be a bit more complicated, but we're kind of mushing this one into one today. So just to review real quick, some methods we have for factoring when we have two terms. We want to use, we want to check for a greatest common factor. So what's the biggest number that we can divide out of both terms and possibly variable. You can see 5-1 for kind of some examples of that. And then difference of squares. So that one is when we have two perfect squares and we are subtracting them. So when we talk about perfect squares, we're saying 1 squared is 1, so 1 is a perfect square. 2 squared is 4, so 4 is a perfect square. So if we're looking at all of these perfect squares, when I'm referring to them, these numbers over here, these are the perfect squares because they have a perfect square root. It's good to have those kind of at the top of your brain so you can recognize difference of squares pretty easily, because those factor nicely. If I have something squared, whoops, not plus, minus something squared, that factors out to a plus b, a minus b. So if I have x squared minus 16, that's going to factor to x plus 4, square root of 16, and x minus 4. If I have something like 4x squared minus 25, that's going to factor out to 2x plus 5 times 2x minus 5. So if you can see those perfect squares, you're going to be in great shape for that. When I have three terms, generally speaking, but not always, three terms, if I have ax squared plus bx plus c, so I have a full quadratic, then generally speaking, I'm going to use box and diamond factoring. And again, for a full rundown on that, you can go back to the 5-1 video. So, multiplying fractions, just to remind you, when we are multiplying fractions, we multiply straight across the top. So 4 times 2 gives us 8. Straight across the bottom, 9 times 7 gives us 63. So if you notice from here to here, we're really just kind of mushing this into one fraction and just saying these are being multiplied. So it's the same thing when we have variables. If this is all factored, we've got 5 times x plus 7, x minus 3, x plus 3. When I multiply these two rational expressions here, really, I'm just smushing them into one. And then I want to simplify, look at what I have in common on the top. Remember, I'm able to do this part, the simplification, because this is 5 times x plus 7 times x minus 3 times x plus 3 divided by x minus 3 times 5 times x plus 7. Some people note this a little bit better if everything is in parentheses. So once you got everything being multiplied and no addition outside of those parentheses, then you are good to start dividing things out. X minus 3 over x minus 3 gives us 1. 5 over 5 gives us 1. X plus 7 over x plus 7 gets us 1. So all I have left then is that x plus 3. And that's going to be on the top of the fraction where it currently lives. So if we have a starting expression here and the various sections, the numerators, denominators are not factored, we want to factor each of those parts first. So the first one, 5x squared plus 35x, 5 and 35 are both divisible by 5, so I'm going to divide out a 5. They're also both divisible by x. So then I want to know what would I multiply 5 by if I were to distribute to get, 5x by to get 5x squared, and that's going to be x. What would I multiply 5x by to get 35x, and that would be positive 7. So that's my factored form. That one's just a greatest common factor because It's only two terms, and it's not being subtracted, so it can't be a difference of squares. If I go over to the right to x squared minus 16, two terms again, I can't have a greatest common factor with that because x squared has no coefficient and 16 has no x, so there is no common factor there. But I am subtracting, and those are both perfect squares, so this is going to factor to x plus 4 times x minus 4. It doesn't matter, by the way, if you put the plus or the minus first, just that you have one of each. Down over here, x minus 4, can't do anything with that. That's not factorable, nothing's being squared. So that one just stays x minus 4. And then 10x plus 70. 10 and 70 are both divisible by 10. We know that for sure because they both end in a 0. Anything ending in a 0 is divisible by 10. 10 times x gives me 10x, and 10 times 7 gives me 70. So, and you can always check these if you go through and you distribute. That's going to give me 10x and distribute plus 70. So that's one way to kind of check to make sure that you've factored it correctly, is to multiply it out. So then I want to take my factored form of everything. So the 5, I don't want that in yellow. That's not a very visible color. So 5x times x plus 7. And I'm going to go ahead and make this one fraction instead of the times. That's just 1. Because when we're multiplying fractions, we're just multiplying everything on the top. So then I'm going to do the x plus 4 times x minus 4. The x minus 4 from up here. And then 10 x plus 7. So first I want to take out the common factors. So I've got x plus 7 over x plus 7. Got x minus 4 over x minus 4. So let's write out what we have here and see what we want to do with it. So I've got 5x and then x plus 4 on the top. And then I have 10 on the bottom. That's all I've got left on the bottom. Now, I can't do anything with the x's or the x plus 4, but I can do something with this 5, with this 5 over 10. Because 5 over 10, or 5 and 10, are both divisible by 5. So I can reduce that to 1/2. So this can just be x times x plus 4 over 2. So that would be basically like the 1/2 would be right here. I don't really want the 1 there. It doesn't make it wrong, but that's what we have there. So that's our final answer. That's as much as we can simplify that one. So for practice, first I'm going to take this x squared plus 3x minus 10. And I'm going to factor that one. I'm not going to use the full box and diamond. I'm just going to go ahead and use the diamond. So I got negative 10 for my top number because that's the first and last. My middle term is 3. And I factor 10, I've got 1 and 10, 2 and 5. If they multiply to give me a negative and they add to give me a positive, then I need my smaller number to be the negative number. So the pair that works for this is negative 2 and 5. So this top one right here factors out to x minus 2 times x plus 5. Next, I'm going to just take my x minus 2, can't do anything to factor that, and put that as x minus 2 on the bottom. Next up, I'm going to take the x plus 4, can't do anything with that, so I'm going to just make that x plus 4, and I'll lengthen my fraction bar there. And then finally, change colors one more time. My 6x plus 30. 6 and 30 are both divisible by 6, so I'm going to factor out a 6. 6 times x gives me 6x, and 6 times 5 would give me 30. So this would be x plus 5. So that's each of those little parts factored as much as possible. And then I want to start canceling stuff out. So I've got an x minus 2 on the top and x minus 2 on the bottom, x plus 5 on the top, x plus 5 on the bottom, and all I'm left with is, no, I made a mistake. So let's come back here. I didn't write the whole 6 times x plus 5, so this right here should be, that didn't quite look right. 6, wow, messy 6. 6 times x plus 5. All those little details we got to watch out for. Okay, my apologies for that. So now I can cancel things out. X minus 2 over x minus 2, x plus 5 over x plus 5. And now I have x plus 4 on the top over 6 on the bottom. And remember, I can't cancel, I can't do any canceling here because I'm adding now and I'm not just multiplying and dividing. So that's multiplication for rational expressions. Okay, so now what we're looking at is how to add and subtract fractions with a common denominator. So we'll do the fraction ones and then we'll do some rational expressions. So back to reminding, when you add and subtract fractions, the pieces must be the same. We must have a common denominator. So what that means is if I have a circle split into 2, each of those are 1/2. And if I have another circle that is split into 4ths, and I want to add up this section and this section, I have 1/2 on this side and I have 1/4 on this side. So I can't say how many fourths or halves I have until I change this into a common denominator. So I change this one so that now I'm in 1/4 and 1/4. So here I have 2/4 plus the 1/4. So they have to be the same piece. And a lot of people struggle with fractions. It's a really, really common problem, but it's in part because they avoid them too by turning them into decimals. As we go, we don't want to turn anything into decimals here. So here we've got 3 over 5 times 7 over 5, plus 7 over 5. So I'm just going to add the tops, 3 plus 7, add the numerators, equals 10. 5 stays exactly the same. The denominator does not change. So once I get down to a single fraction, simplify the top and simplify the bottom, then I can see if I can reduce that. In this case, 10 divided by 5 gives us 2. Remember, a fraction is just a division problem. So next section, next video, we'll do uncommon denominators. It's a little bit more complicated of a process. Today we're going to be working with common denominators. So in this first example, I have 7x on the bottom, 7x on the bottom, stays on the bottom through the whole thing. What I'm going to do with the top, I'm not going to factor anything on the top because then I can't add things together unless they're the exact same thing. So remember, adding and subtracting, you have to have like terms. X's can only add with X's. X squareds can only add with X squareds. So if I have X plus 3, I can only add that to another X plus 3. So I don't want this in factored form yet. What I want to do is take my my like terms. So my like terms here, 3x squared and 4x squared, give me 7x squared. And then 6x and negative 10x give me negative 4x. So then that's when I want to simplify, if I can. So I want to take the 7x squared minus 4x and factor that part. 7 and 4 don't have a common factor, but I can take an x out of both of those, so that would give me 7x minus 4. And on the bottom, all I have is 7x. So I've got x times 7x minus 4 over 7x. So now everything is factored. The only thing I can take out here is the x and the x. So this is going to give me 7x minus 4 over 7. And I can't do anything way back here, or not way back, but back here. A lot of people want to take out 7x and 7x squared. You can't do that, one, because we are adding and subtracting, and two, mainly because we're adding and subtracting. But you also want to make sure they're the exact same thing and in factored form. Okay, so now we have a new one to practice. So we're looking at this one right here. First thing we know is that our bottom is going to be our denominator is going to be 3x minus 12. So then we want to look at our like terms. This is adding, and so we can just kind of take it across here. We have negative 5x and a positive 5x. That's going to give me 0, so I don't have anything to do to carry that over. And all I have left is x squared minus 16. So once I'm down to one fraction, I've done the adding or subtracting, I want to factor each part. X squared minus 16 is a difference of squares, so I'm going to factor that to x plus 4 times x minus 4. And I'm going to factor the bottom to 3, because those have a greatest common factor of 3, 3x minus 4. And then the x minus 4's go out. I've got x plus 4 over 3. That's my final answer on that one. Subtracting you have to pay a bit more attention to, because when you subtract, you're subtracting this entire thing, which means you need to distribute the negative. Go back to the pointer. So this negative, remember the bottoms stay exactly the same. 2x plus 32, 2x plus 32, 2x plus 32, 2x plus 32. But the tops, the 3x squared plus 6x, we're going to carry over. And then we're going to subtract, we're putting this in parentheses. So the 2x squared minus 10x needs to be in parentheses. And the reason for that is that we have to distribute the negative to the 2x squared to get minus 2x squared. And negative times negative 10x is going to give me a positive 10x. So we have to watch out for that detail before we combine the tops. So once we're combined up here, we want to look at our, I guess when I say up here, I should point out, we want to look at what our like terms are and what we can combine. So we've got 3x squared minus 2x squared, which is just 1x squared, or x squared. And then 6x plus 10x is plus 16x. On the bottom, 2x plus 32. Then we need to factor both the top and the bottom. So the top is just a greatest common factor of x. That's all we can do with that one. And that's x plus 16. And on the bottom, I'm going to factor out a 2, because those are both divisible by 2. So that's going to be 2 times quantity x plus 16. So our x plus 16s go, and we're left with x over 2. So I'm going to zoom in over here on this one. First, to get this down to one fraction, we know we are going to have a common denominator of 3x plus 3. On the top, we're going to have 3x, pencil's not working, minus 4, minus the 2x, minus 5. So then we want to distribute that. So we'll have 3x minus 4 minus 2x plus 10 over 3x plus 3. Combine my like terms, 3x and negative 2x gives me x. Negative 4 plus 10 gives me plus 6. And on the bottom, I've got 3x plus 3. I can divide out a 3 from that and get x plus 1. And that's really as far as I can take that one, because I don't have any common factors on the top or the bottom to divide out. Okay. So to sum up, when we are multiplying rational expressions, so once you get past the factoring part, this is important to remember the order in which you need to do things. When you're multiplying, you factor first. Then you do the multiplication and simplify. When you're adding and subtracting, you add or subtract to get to one rational expression or one fraction. Then you combine like terms. And then once you're in one fraction, that's when you factor. So factor first when you're multiplying, factor last when you're adding and subtracting. Then you'll want to simplify after that. But a lot of times people want to factor when they're adding and subtracting, or they want to combine like terms when they're multiplying. So make sure you're paying attention to when you factor in these two places. So that is 5-2 is the multiplication. 5-3, part A, is adding and subtracting with the common denominator. That's going to be the proficiency level version of adding, subtracting rational expressions. And then 5-3, once I get that video posted, that will be uncommon denominators. That's going to be the highly proficient version of adding and subtracting rational expressions. Next section after that, we've got 5-4 of graphing rational expressions, and then we're done with Unit 5. So have a lovely day.